up on the bike, they're just loud. I think my students will say both. All right, so hi everyone. As Elizabeth said, I'm Dr. Dawn Wendell, and I'm currently a senior lecturer in mechanical engineering. And today I'm going to tell you about my story, which is really a journey. And you're all very lucky because you know what the end point is, but when I started off, I definitely didn't know that this was where I was going to end up. So that's why the subtitle here is how a nice, quiet girl from suburbia ended up with a PhD in mechanical engineering from MIT. So why my STEM story? Well, the reason I want to tell you my story is today you're learning about a lot of really cool science and engineering topics. And especially for some of our younger audience members, you might think this stuff sounds really cool, but you don't really know what to do with it other than, wow, that's really cool. So I'm going to tell you how I found the things that were really cool when I was younger and how I followed those, my passions, how I followed the things that interested me in a way that wasn't maybe the most linear, but was a lot of fun. So I hope that my story can help you get some ideas of how you can follow your passions as well. So as I said, we know the ending. I'm Dr. Dawn. You may have seen my videos online. You may have heard about the new maker portfolios that are in the MIT Office of Admissions that are used as part of our application process now. That was an initiative that I did when I was in the admissions office as their technical expert and assistant director of admissions there. So I'm out there. I talk about STEM. I talk about engineering. I talk about science. It's really great. But that was not always the way it looked like it was going to turn out. So, here I am. Now you all know how old I am. So this is me when I was small. That's my aunt there. And at this age, my life goal was to be rainbow bright. You know why? She had really cool outfits. Really colorful, really pretty. I was going to be rainbow bright. If you asked me what I wanted to be when I grew up, that's what I said. And so here I am actually with one of my favorite toys. My parents had this set of wooden blocks. They were really plain. They were just a bunch of squares and rectangles and circles and half circles. I thought they were the coolest things ever. And I spent unreasonable amounts of time building towers. And I had a much younger brother who probably would have been about 1 year old in this photo who spent a lot of time knocking it down. That was, I think, his motivation to learn to walk was so he could come over and topple all of my towers. But, you know, I still had this great sense of curiosity. I wanted to see how tall I could build this tower. When my aunt came to visit from Hawaii, which was very far away because I was growing up in central Connecticut, the first thing I did was show her the tower I had built. And I really loved exploring. I spent a lot of time outside, made piles of rocks, made piles of all sorts of things. I thought this was great. So me as a kid, wanted to be rainbow bright, and I just like kind of playing around with things in my environment. So I went to school. I took normal school classes, I went to public school, and the next really kind of interesting thing, in hindsight, didn't happen until high school. Now it turned out I was pretty good at this whole like kind of science and engineering classes. Well, we didn't have engineering classes actually, but science, I was good at science, I was good at math. I was also good at writing and English, social studies. So my parents didn't really know what to do with that. They just thought, oh, she's good at things. But they made sure to sign me up for all sorts of different activities. So for example, here's me in 9th grade. Can you tell who I am? That one. The red hair should give it away for most of these photos, but there is going to be a quiz at the end, so pay attention. So, for example, here is a day-long activity that I did with some other high schoolers about bridge building. Now, my big lesson from this is bridges are boring. I don't think that's what my parents hoped for me to discover. But I realized that I just wasn't really into bridges. I mean, I built really tall towers when I was like 4, so bridges just weren't that cool to me. But the thing is that my parents didn't just let me say, oh, I'm not into bridges. My parents encouraged me to keep looking for things that I was excited about. They kept signing me up for all these different activities and making sure that I was going to different things after school and seeing what else was out there. So one of these things that I just randomly went to at my school was this new little club that got formed my freshman year called the First Robotics Club. Now this is a club that competes in the First Robotics competition, which is an international competition of robots. Now, robots are not like bridges or towers, so I was like, oh, this is new. So, can you tell who I am?
Yes.
The only girl.
The only girl. There's other girls too, but they're actually hiding out of the photo. So here I am, and here we are brainstorming as a team different ways that we're going to play this game, this challenge that was given to us this year for First Robotics. It was basically picking up big inner tubes and stacking them more than 6 feet high. Really, and I had no concept. Like building a tower, I could do. Building a bridge, I could do. Making a robot, lift up this inner tube from the ground up to 6 feet high, I had no idea. Here I am, I can barely reach it with this little model we had made out of cardboard. So I decided that robots were cooler than bridges. And so I stuck with this club. I thought this one seemed like it had a lot more promise. I was learning a lot more. It was a lot more fun. I was doing things I didn't know how to do. So we learned all sorts of different little things. We learned about batteries. We learned about motors. Who am I? Got it? Got it? Good. Good. All right. See, there's more girls there. They were just hiding. So then it turned out we were actually able to build a robot as a team. And can you find me in this photo? Where am I? I've got my head in the toolkit. I got my head in the toolbox. I was like, this is awesome. So here I am digging around, probably finding a hammer or a screwdriver or something, a hammer with the robot back together. And my dad, it turns out, likes really arty photos, so who am I in this one? Yeah, now good. So this was a really great experience for me, and I worked on my high school's first robotics team for all of high school. Each time, each new year, I learned a whole bunch of new concepts. I worked on mechanical engineering sub-teams, I worked on drivetrain, I worked on the different lifters, I worked on the electronics, because I didn't know anything about electronics other than you turn on a switch and lights come on. So I thought I would just try out everything. And so what my parents had instilled for me when I was a kid of just trying things out and seeing what you love, I just kept doing that. Once I found an area I liked, I just tried everything inside of that area. And so in the end, I decided my lesson was I love robots. I love robots. Robots are awesome. So that was me coming out of high school. I love robots. How does that get me to where I am now? Well, what I was told was that if you love robots, you should be an engineer. I didn't know what engineering was before I got to high school, before I started doing all these different activities. This is how I discovered engineering. And then people told me, you want to be an engineer. Okay, so I went to college for engineering. I actually came right here to M.I.T, and I decided to become a mechanical engineer. And I got involved in all sorts of other things again, because once again, I'm in a whole new place. Boston's tons of fun, Cambridge is tons of fun, M.I.T is tons of fun. And there's all sorts of different activities there that I hadn't gotten to experience yet. So, things like competitive robotics. Has anybody ever heard of the TV show BattleBots? You see, this reference is getting old, I know. It was like back when I was in college. Yes, so I did BattleBots. I unfortunately have no pictures of me driving my robots because those people were too busy watching them. But so here's actually one of my robots. I had 3 different robots that I built and drove. And at one point I was the 20th ranked 20-pounder in the nation. So that was pretty awesome. I was really proud of that. And I thought, this is awesome. But then I was like, okay, this is cool, this is good. But now let's leave the ground. I didn't know how to fly RC planes. I was like, this is gonna be great. It turns out I am not super good at flying RC planes. This plane went up and down a lot, mostly down. Spent a lot of time on the ground getting repaired by me, and I discovered this actually wasn't my favorite thing ever. And I'm not particularly good at it, even though I practiced a lot. But I tried it out. I learned a lot of new things. And also, I got really involved in some class projects, such as this is one of my favorites, called the Fabaroni. Fabaroni. This is a 3D pasta printer. You know, sometimes you go to the store and you get those cute little shaped pastas, like you get mac and cheese SpongeBob SquarePants. Yeah, so we thought it would be cool to be able to design your own macaroni shapes. You know, I don't just want the ones that come from the store, I want to make up my own. I want Star Trek shapes. I want something else. So, a team of students and I built our own 3D printer that printed pasta dough. It was super fun. It was fantastic. I loved working with everyone. I loved working in the machine shop, and having something that actually worked in the end was really cool. Although we never ate any of the pasta, it was more of a proof of concept, really. So that was really fun. And some of the other things I discovered when I got to college is it turns out I picked up a few other hobbies that you maybe don't consider engineering per se, but that I really love. So it turns out I love baking and I love knitting. And so I actually can be found all over Boston knitting, especially when the weather's warmer and you don't have to wear gloves. I'm always up at the bus, I'm sitting at the tea, and I'm knitting. And so what do all these things have in common? Well, I decided that actually what I really love is creating things. And I only would have discovered that by going out and trying all sorts of different things. One of the things I didn't love about RC Planes is that I actually didn't really build the one I had. I bought a kit, I put it together, I tried to fly it. I got much more satisfaction out of designing my own fighting robots, even though they often got destroyed, because I learned so much more through the process. The same thing with knitting, I love the process. I love the process of cooking. I often give away most things I cook. I love the process. So I love the process of creating. That's what I learned by going to school for engineering. Isn't that weird? So now, PhD in engineering. Obviously I stuck around. And the question you might be asking is the one my parents ask me all the time. Why? Why? Why a PhD in engineering? Because when I started my PhD, it turned out that I didn't really have this vision of teaching. I didn't have this vision of still being here at MIT after all these years. But I realized that there were still so many things I wanted to learn and try. So I found all sorts of fun adventures earlier on, and I saw that there were so many more opportunities. And the other thing that I realized is the longer I was here, I saw that scientists and engineers are the ones who make the new discoveries. They're really the ones who are creating all sorts of different materials. So I wanted to be involved in that. Now I'm going to tell you the story that actually was the story that inspired me to get a PhD. It's a story about science. So how many of you have ever been to a lake and seen water striders? Maybe a river. So there's these little bugs.
Yes.
All right, so you're mostly familiar with them. They're pretty small. They sit on the water. And they don't really swim, they like glide, right? So they're gliding, water striders. Now, 10 years ago, we didn't know how they walked on water. I want you to think about that for a second. The year 2000 came and went, and we did not have physics that described how water striders could stride on the top surface of the water. We had physics that could describe why they floated. We understood that part. But we actually didn't understand a real subtlety of how they were able to propel themselves across the surface. There were two competing theories. We actually didn't have an answer. Now, pretty much everyone raised their hand when I said, have you seen a water strider? That means that something that you have seen in your life that you probably just thought was like, oh, this bug, we didn't understand the physics of it. I went to a seminar from the professor who actually figured this out. When he told me that, my mind was blown. And I decided that this was my new challenge. I knew how to build things, but I wanted to understand science in a different way. And so I'm going to answer the question is, so now we actually know. So about 10 years ago now, this professor and a couple students had an idea of how to settle the debate between these competing theories. So they had an idea, they made some experiments, and actually these are the images that were the cover of Nature that showed these vortices here, both in this image and this image, show that that is how the water strider is able to propel itself across the surface of the water. It's vorticity. So I thought this was amazing. And not only did we understand the physics of this, so this was done in a project jointly between the math department at MIT and the mechanical engineering department at MIT, we were then able to use the physics gained from that to build a mechanical water strider. So this is what they did. They had an idea, they did experiments, they figured out the answer, and then they were like, now we're going to build a robot. I love robots, you know that. I thought this was amazing. I thought this was incredible. And I thought, if there are still problems like this out there, that things that you can see every day aren't fully understood, I am not done in school yet. And it turns out the person who built this little water strider robot who did these experiments is a super cool person. And I ended up getting my PhD from the same lab that he did, because I was so inspired by the fluid mechanics he was doing. So we had the same advisor, still one of my heroes, and he's a genius for what he can do with both engineering and physics. So anyways, which one am I in the photo again? You gotta figure, you're good at this, you gotta figure it out. Yeah. So that's why I went on to get a PhD. So for me, my journey in engineering is because engineering is really an outlet for my creativity and my curiosity about the world. I like designing things, I like building things, I like creating things, I like understanding things. And the really other cool thing that I discovered the further I went along and the more I learned is that I could travel around the world and meet other people in engineering and in science who are just as excited about the things that I am. And they want to talk about this, and they want to share ideas, and they want to collaborate. I got to go to New Zealand, China. I got to live in France when I graduated with my PhD. My mom was an art major. She never got to go to France. And I got a job in Paris because I was an engineer and they needed someone with my specific expertise to go over there and do fluid mechanics research in Paris. It was awesome. So hopefully through this you've seen that you can really have a nonlinear journey. So all these things that you're seeing tonight, all these different ideas, these different explanations, all this science and engineering and awesomeness that's out there, you should get out there and figure out where your passions lie. Get involved. Follow those passions, ask questions, keep exploring, because maybe the first, second, third, 12th thing you find is not going to be the thing that's most exciting for you. And it's also okay if you don't have all the answers right now. Maybe you don't know where your life story is going to take you yet. I didn't know where mine was going to take me. But as I said, so I got the doctorate. I finished my PhD in mechanical engineering. I got a job in physics research in fluid mechanics in Paris. I lived in Paris for a year. And then my journey took another turn. I came back to M.I.T. as a technical expert in the admissions office, where I got to work with fantastic young people all over the world and tell them about the awesomeness of M.I.T. And now, I've transitioned again to lecturing. Because just as you've seen here tonight, I love to talk to people. And so it's absolutely incredible for me to get to talk about engineering to students and share with them my passions and my discoveries and help them discover engineering for themselves. So thank you very much. I'm going to stick around for a couple seconds and answer a few of your questions, either about the technical or non-technical side of my life. And then I'll hand it off to the next presenter where you can hear about more awesome STEM activities. All right, questions? Silence? Intimidation? Uh-oh. I start lecturing next month, that better not be what's going to happen.
No questions on robots?
You all know how to build robots now? Yeah.
How exactly do water striders stand on water?
All right, so the question is, how do water striders stand on water? So there's standing and there's moving. Turns out those are very different things. So with standing on water, they have these long legs that are hydrophobic, that means that are repelling water. And so the amount of area that they have in each of their legs actually keeps them afloat. So it's as if you took 4 huge inner tubes and tied them to each of your hands. You wouldn't sink either. So they are taking advantage of geometry in that case. Now the thing is, if you tie these huge water tubes to your hands and feet, and you were floating there in the pond, and you tried to move, the water tubes, it's like they're slippery, right? So water's like a slippery surface. And so you might be moving these water tubes and not going really anywhere. You can't just be stuck there. Because when you swim, you actually paddle, right? A doggy paddle or like a real person swimming. That's not how I swim, but like I think this is what happens when you really swim. And so people don't just float on the surface, and water striders don't just float. But the question was, how are they able, if they're not putting their legs into the water, to create that propulsion? So they're actually using some creative physics that have to do with the surface tension of the water, and that's why you're able to see these vortices. Those vortices are able to interact with each other and propel the water strider forward. And that was one of the theories that was out there. There were some other competing theories, but no one had actually really figured it out, because they were like, okay, the water strider's on the water, floating is good, but it wasn't clear how they were actually able to go forward. I thought that was crazy. I was like, wow, how do we not know that? Yeah?
Because I noticed when I look at it, lots of water bubbles and kids like this, it's thin layer, and if you smack water, you get like a layer or something.
Yeah.
And why do they can stand on that layer and they're like this?
Great question. Great point too. So water has some really interesting properties. The question is about sort of the top surface of the water. Now that's called surface tension. And the water striders are able to take advantage of surface tension in order to float. And people debated what elements of surface tension were helping them propel themselves. So that was another one of the challenges. There's a lot of really great stuff out there about surface tension actually. And I could have given a whole lecture about all the awesomeness that is out there. Here's a good take-home experiment for you all about surface tension. So if you take Cheerios, you float Cheerios in a bowl of milk, don't put a whole lot, a bowl of milk, put a couple Cheerios, and you'll find that if they come close together, they'll actually stick. Which is weird, right? Like, there's no glue. Why are they sticking? And they're sticking as a result of surface tension. There's actually energy minimization that happens when the two Cheerios come close to each other. And so that stickiness is actually a result of surface tension. It's really cool. That's like one of my favorite experiments. There's another thing that, when I was 4 years old, I wanted all my Cheerios spaced out in the bowl. Couldn't figure out why they wouldn't stay where I put them. Physics. It's physics. It's always physics' fault. All right. Oh, one more question, and then we're going to turn it over to the next presenter.
What's the biggest thing you made?
Oh, the biggest thing I made. Huh. Do you mean the largest or the most complicated? Ooh, the most complicated. That's hard. I think about all the projects I've worked on with lots of different people. There's probably some of those that are much more complex. I think probably if you talk about complexity in the shortest amount of time, it was the Fabaroni. So we went from the idea for the 3D pasta printer to a pasta printing device in less than 2 weeks. So that had a huge amount of complexity, and we all worked really, really hard to finish it up that quickly. But it was just something that we wanted to do concept, and it was really, really fun. So it doesn't have to be a long-term project either. It can just be something fast and fun. That's great. Thank you very much. Enjoy the rest of the evening.